Okay, so hello everyone. Today we will be solving min-max array transformation from C++ STL Sheet. So let's start by understanding the question. So the question says that you would be given an array, okay, which is in non-descending order. That means it is sorted in increasing order. Now you have to like if this is an array, okay, and they have sorted in non-decreasing order. That means it is an increasing order, and they have made another array named as b. Okay, now how is b made? Like you create an array d is corresponding to every index ai, and you add that di value to ai, okay, and get the value of bi. Now b is also sorted in non-decreasing order. So let me just explain a little bit about like what is going on here, so then we can move forward to the question. So let's say the array initially was given as 1 2 1 3. Okay, let keep it that simple, and you create a d vector, and you can create it of your own. So you, let's say it's 2 1 5, it can be any value. So now when you add these up, it gets 3 3 and 8. Okay, let's take an interesting value. So let me take this as, let's say, 5 here, 5 and 2. So now that becomes 7 and 5, right? 7 and 5. So like you can you constructed this second array b, okay, from this a array. Now you even sorted this, okay. So it became 357. So the original array was 1 2 3, and you made it 357 by adding a d value, okay. So now question is saying that you would be given this b vector, and from b vector you need to, like, for each indexes, like for d, this is a d vector, right? So for each indexes d vector, you need to find a d minimum and a d maximum, such that when you add that d minimum in this, you get this, you can obtain this whole vector, and when you add d max to this, you can even obtain this whole vector, okay. So you need to do so. So let me first explain you how would you get a minimum, like how do you get find the range of minimum value, right? So you need to find this, you can even see a minimum value and a maximum value, okay. So you need to print both the arrays. So let's take an example. So let's take this array 2 3 5. So this was original vector a, and new vector 7 11 and 13, right? Now like these have, or values have been shuffled, right? So that's why, so you needed to first understand like why range concept was involved, because like after obtaining the array it was reshuffled. So now it is for sure that if for every I, bi, it is greater than equal to ai, right? Because you are adding a d of a non-negative value, okay. Di should be greater than 0. So that's it. For every I here, bi is greater than ai should always obtain, it should always hold, right? So that's why. So imagine that like what can all be the values of bi. So let me first tell you in the graph format. So if you assume that this was an array, okay, imagine that this is the number line, and some points were there in this, some points of the, if a first array were given. So let's think that these all were points of ai. Now when you add a value bi particular to that, so obviously the resultant array would be either like it will be equal to this, okay, like first scenario. Second scenario would be it can be greater than equal to this, right? Like it can be, it can have a value greater than equals to this can be possible, or even this can be possible. But a value, let's say like this is the, if this is the original line, so a value, first value cannot become less than this, right? Because it has to be greater than that value. So why I visualized this, because it will help you understand that why, um, like why, what, how can you find the minimum range. So let's say that if this was the first array, this is the second array, right? This is the first array, the second. So think that for this value, if you are for trying to find what is the minimum value, obviously it would be the first, like the first value which you find, the first value in the b vector which you find a greater than equal to value than that, that would be minimum by like also you need to construct such that you can also even construct these all values. So if you add a positive number to these value, you can even get this number. If you add a positive number, you can even get this number. Why I'm telling you this? So like you, you can even think that why not add right sorry, why not add okay, yeah. So okay, it's hanging, it's just a minute here. So you might be telling that if these all are there for this value, why are you not taking a value here? Like why it can't be minimum? Because if a minimum value is present here, it cannot exceed those. So a value which is greater than equal to that value in the second array, that has to be the answer. And obviously, if you pick up that, then other values element are also possible. Let's explore this situation more briefly. So imagine that this was there. Now let's say for this element you are trying to find which is the minimum value element, right? So it might happen that, so for sure, like corresponding di value, right? Corresponding di value that is greater than equal to the ai vector. So if you find the corresponding value, this is obviously greater than equal to this, right? This is obviously greater than. So one of the possible answers is that you take that corresponding value. So for example, in this value for 20, you can even pick up 33, right? But you can even find a minimum value, right? So if you find a minimum value, let's say 22, right? So for this value, if you're trying to find a minimum value, because you're trying to find a greater, like this is obviously greater than this value, but it might happen that this value is also greater than this value, right? So I hope you get it. So let me restate it once again. Like for every value, it is assured that ai it is greater than, sorry, bi it is greater than equal to ai, right? So, okay. So this value is greater than this. Okay. This value in B vector is greater than this. It might be possible that this value is also greater than this value, right? Right, right. So why? Because you can take this example 10, 20, 30, and second vector was 10, 22, uh, not 10, let's say 22, 25, 30. It might happen, right? Like this is even greater than this value is also even greater than equal to this, but it might happen that this value is also greater than this value, right? So now how will you think that, right? Now how would you think that, like, so to find the minimum value, you can find the first index in the b vector such that it is a value bi, or let's say bj, that is greater than equal to a. So that value would be our answer. Okay. So finding out the minimum is very easy because you need to find a, you can even do a low bound, or we can just directly do by a two pointer method. So just let me show you code and I will again show you by like the second part itself. So this is the first part. So I input the vector and I initialize a two pointer. Now there are two scenarios, right? So like if I'm particular, like initially j is at 0 and I is at 0. Okay, so I is here at 0 and j is here at 0. Now if ai is less than aj, right? If sorry, if ai is less than, if ai is less than equals to bj, that is obviously true for the first case. So I can just directly print that value, right? And increment the I pointer to find the next value. Now I will not shift the j pointer because it might happen that this value is always also greater than I, this I value, right? Now yep. So for this I value, now you check again if AI is again greater than this, right? Uh, sorry, if AI is again smaller than this value, right? So let's say 10 and 12, and BI was 20 and 30. So if 10 and 20, then you print 10, 20, and 20 minus 10, that 10 is the minimum value. Then for even 12, you find that 20 is the minimum value greater than this. So you print at 20 minus 12, which is 8, right? Now if you get a value ai which is greater than this value, so you can't take this j value, so you have to push the j pointer till such that it becomes a greater value. So if the first condition is satisfied, you print that value and increment the I pointer. Otherwise you push the j pointer, like you push the j pointer such that you push it till ai is great value is greater than bj. I hope you get this. So this is how you would get the first part. Okay. Now to find for the second part, right? Now you need to find what is the maximum value you can obtain. So let's start it from backwards because it would be easy to understand. So for this last value, let's denote I at n minus 1 and j is also at n minus 1. So now, like obviously aj is greater than equals to, sorry, bj is greater than equals to aj, because it is of firstly satisfied. So for this value, you can obviously find this maximum difference. Now you now check for this whether can you can you take this value and can you say that okay, I can have this my j value as maximum answer. When can you say so? Think, like, when can you say so that this can be, like, my this j pointer can be one of my valid answers if this value ai, okay, and this, if and this is ai plus 1, right? So now, like, ai plus 1 is this sorry, this value ai plus 1, it is now less than aj. Now when you are checking for ai, you need to, like, this can be the maximum value when the corresponding bj, right, that is greater than ai plus 1, because then only if you assign this value to ai to this one, then you need to have a positive value d such that you can add to ai plus 1 to make it as equal to d. So when so when what bj, sorry, you are at this I pointer. So when bi, right, when bi when bi it is greater than equal to a of I plus 1, right? Like when this value would be greater than this, then you can correspond this to this value. Otherwise, otherwise what you can do, if bi it is less than aj, then you have to just corresponding this value to the corresponding. So let me take an example. So let's say ai is 10, ai plus 1 is 12, okay, and let's say this j is 20, and this is 19 or 18, okay. So now in this case you're mapping 12 with 20, okay, it can possible. You're trying to map 10 with when I is here, you are trying to map 10 with 20, but this is only possible when this value is greater than this value. Why? Because you would have to add a positive of 8 to obtain this value, then only you could do this, right? So then I need to proceed this. However, if it can also be possible that what my this value is 10, or let's say yeah, let's say it's 11, because this has to be greater than this value, greater than equal to this value. So let's assume it is 11. Now if you're trying to map this value 10 with 20, you can't map this 12 with 11. Why? Because it would not, if you have to then add a negative one to make it match. So to do this, so what is the maximum value of d which you can add to 10? You can just map it with the corresponding pair itself and remain this pointer. So that's what I did. So initially I calculate the max by putting the last pointer to j, and I push into a difference vector. Now I am traveling from am second minus I n minus 2, and if ai plus 1 that is less than equals to bi, right? If ai plus 1 that is less than equals to bi, right, then I can even I can just map the higher value. I can even map the higher value. So I do nothing, like I don't do nothing. Otherwise it is not the case, then I have to map this corresponding ai to that corresponding baj. So I then place my j pointer to I pointer, and I calculate the difference. At last I have to print the difference, which I reverse and print it because I was calculating from backwards. So yeah, I hope you got my explanation. Thank you.